because the order changed and the grouping changed. So I have applied both properties to make that true. Let me show you when you would use this and when you'd want to use it. Check this out. Who can tell me what that answer is? Who said that? How'd you get that?
1/3 times 3 equals 1, and 1 times pi over 3 pi over 2.
So, wait a minute, 1/3 and 3 are not together. 1/3 and 3 have a pi over 18 in between them. Did you just kind of move them around in your mind? So, in your mind, ladies and gentlemen, here's what a lot of you guys did. You said, that's going to be hard, and so here's what I'm going to do. These two guys go naturally together. 1/3 times 3, they're reciprocals. You multiply 1/3 times 3, you get 1. So in your head, here's what you do. 1/3 times 3, and you put those two guys together mentally, times pi over 18. Because that's just 1, and 1 times anything is just the thing. Ta-da, you're through. Now you could go 1/3 times pi over 18 is pi over 54, and you could do that. But there is a logical way, a logical reason for moving things around that you're multiplying or moving things around that you're adding. Okay? In this case, things I'm multiplying, these two guys go very nicely together, and we chose, at least mentally, to put them together and to simplify. So that's why, and that's an occasion about when you would use the commutative and associative properties. Just to make life easy for you. Any question about these guys? All right, let's look at some further properties of real numbers. Something beyond the commutative and associative properties. And by the way, here's one I did not write down formally, but it's one you'll be familiar with. Looks like this. It's what happens when you're multiplying a single entity times either a sum or a difference. What's the property that we apply? Distributive, right? So 2 times the sum of a plus b would be what sum? 2a plus 2b. You're familiar with that? You distribute the 2 over both parts. And this last one, latter one would give me
3c minus 3b.
It works for sums or differences. It's called the distributive property. And we're going to use it often. We're especially going to use it in the reverse order. We're going to start with stuff like 2a plus 2b in just a section or two from now when we start factoring. We're going to notice these guys have something in common, namely 2. And we're going to re-express this as 2 times the individual parts. So it's called factoring out a common factor, but it's basically an application of the distributive property. Distributive goes that way, distributive goes backwards as well. Either way is an application of the distributive. All right, here's some other properties. Something called an identity element for addition. We got identity elements for addition, we have identity elements for multiplication. The identity element answers a question. Here's a question that it answers. What number can you add to any real number A and identically, that's why it's called the identity element, and identically get that number back? Well, what can I add to A and get A back?
0.
Absolutely. So we call 0 the identity element for addition. Oh, we need to ask another question. It certainly worked for 0, but is there any other such value? is there anything besides 0 that I can add to 7 and get 7 back?
No.
How many think, no, there's nothing else? How many think, I think he's trying to trick me, so I'm not going to answer? You first, folks, we're right. There's nothing else besides 0 that I can add to 13 and get 13 back. Or add to 7 and get 7 back. That's it. So we're going to call this guy, is there any such value? No, no other such value. So we're going to call this guy a unique, what does that mean, unique? One and only? Yep, it's just one. A unique identity element. Unique is the keyword. The keyword. The keyword. It's also a keyword. It's a keyword. But you're going to think, well, so what? We're going to use this when we start talking about exponents, probably next Tuesday. We're going to use this, the fact that there is a unique identity element for addition and for multiplication. All right, identity element for addition, it's 0. The thing you can add to any number and get that number back, 0. We can also talk about an identity element for multiplication, which answers this question. What number can you multiply any number A by and get A back?
1.
1 is the answer. So we call 1 our identity element for multiplication. Of which we need to ask the same question. Is there something besides 1 I can multiply 7 by and end up with 7 still?
No.
No.
Everything no? More bold this time around, and you're correct. This guy likewise is unique. We're going to say, the answer to this question is no. That implies a unique identity element for multiplication as well. So for both addition and multiplication, I have unique identity elements. Now, as soon as you start talking about identity elements, you introduce another concept called inverses. We have inverses for addition and for multiplication. Now, notice the nature of the question that the inverse asks. It says, hey, I'll give you a real number, A. Can you tell me what real number I can add to A and get the identity element for addition, namely 0, as a result? What could I add to A and end up with 0?
The opposite.
Which is in this case is going to be?
Negative.
Negative A. And you have answered both questions that I have with your single statement. Negative A is the value I would add to A to get 0. And what do we call that? The opposite. Very good. These inverses are called opposites. And that's why this is called the property of opposites. It says for every number, there is a number called its opposite that I can add to it and get 0. Is that true? For every number? So for negative 7, what can I add to that?
7.
For pi over 13, what can I add to that? What are you doing to get the opposites? Changing the signs, right? You're changing the sign. So you change the sign of the number, and you've got its opposite. What number do you think might be a problem? Doesn't have a sign, does it? What's the number? 0. 0 is where you always go to find problematic or maybe exceptions to rules. Does 0 have a number I can add to it to get 0? 0. No, yeah. So it does. So 0, ladies and gentlemen, has an opposite. It just happens to be itself. So 0 plus what gives me 0? Itself. So 0 still has an opposite. Just happens to be a little strange. It's the same number. Hey, that would lend itself to some true-false questions. Huh?